Hello and welcome to another tutorial. We are going to continue our learning of Java using ChatGPT, and now we are going to start with a very fundamental topic, which is the primitive types. We know that Java, just like some other languages, supports primitive types, which means the data are really stored as primitives. There are no object wrappers around them, and Java supports this. So the very first question that we should have an answer for is what primitive types are supported in Java. Then we have to look at different primitives. We already know that there are some double and floating points. There are some integer types. Java supports multiple integer types. And then we wanted to also learn that what is the concept of numeric literals. When we write down a number as pure number, like if somewhere in our code we write 10 is considered an integer literal, for example. So let's head to ChatGPT and start by asking about the primitive types. So I'm going to ask what are the what primitive types are supported? What primitive types are supported in Java? And let's see what answer we get. In Java, there are 8 primitive types. Boolean type represents a Boolean value, which has the value of true or false. Byte type represents an 8-bit signed integer. Char represents a single Unicode character. And then a short represents 16-bit signed integer. Int represents 32-bit signed integer. Long represents 64-bit signed integer. Float represents a single precision 32-bit IEEE 754 standard floating point number. Now, the reason it mentions that Java follows this standard because there are different standards for representing floating point numbers in memory. The reason is that floating point numbers, they might not have a limited number of digits, right? So if you have a number like 2 divided by 3, it's a floating point that never ends, right? And obviously you want to use a limited number of bits in the memory to represent such number. That's why you have to truncate it at some point and also follow a specific standard on how the computer interprets the bits as a floating point number. Double is a floating point number which has double the length, 64-bit, and all of these are signed. And you see that Java essentially doesn't support unsigned numbers, right? Floating points by default are signed. Doubles are signed numbers. Int, long, short, byte, these are signed. Char is represented by 2 bytes in Java. And then Boolean is represented by 1 byte. So show me the byte size or the bit size of each primitive type. And here are the sizes of each primitive type in Java. Boolean, either true or false, but inside the JVM, Boolean is 1 byte. Byte is 8-bit, char is 16 bits. So char in reality it's 16 bits. We know that, for example, in C++, it uses UTF-8. That's why if you use the char in C++, it's just 1 byte, right? Char in C++ is very similar to an unsigned byte because it's 1 byte, 8 bits. But in Java, it uses 16 bits just because obviously Java doesn't, it's not just using UTF-8, it's more like using UTF-16 for encoding. Int is 32-bit, long is 64-bit, float is 32-bit, and double is 64-bit. And again, Boolean inside the JVM, it will be represented by 1 byte or 8 bits. Note that the sizes of these primitive types are fixed and not platform dependent. Unlike sometimes, obviously, in C++, there is no guarantee that int is 32-bit. There is only a guarantee inside the C++ standard, for example, that int at least has to be 16-bit, but it could vary from one platform to another, whereas JVM provides these guarantees for all these units, so you really don't need to worry about them. So this is the first thing, right? And the next thing is give me more details about char type. Because char is a very specific type. You can initialize a char in different ways, right? char type represents a single Unicode character, 16-bit unsigned integer internally inside the JVM, and is used to represent characters in the Unicode character set. Unicode is a standardized character encoding that represents most of the world's written languages. The char type is primitive, primarily used to store and manipulate characters. And for example, you can initialize a char variable. So we are defining a variable of type char, and we're using the assignment operator to assign a character literal to it. So this is called a literal. You can also use char type to represent special characters. For example, \n. This is one character, and this is called the escape sequence. And you can also initialize a char with a Unicode character, and you see this is Unicode, which is the hex representation. This is not hex representation, this is the Unicode representation, and it's supposed to be 2 bytes. Remember, each one of this is more like hex, so each one of these characters is 4-bit, representing 4 bits. So 24 is 1 byte, 02 is another byte, right? So char, you can initialize it directly with a Unicode character. The char type is also used in combination with arrays to store and manipulate strings. So in C++, for example, if you want to store an array of bytes, you kind of use char, right? There is no explicit byte type. But in Java, you can use byte. The downside is that byte type in Java is signed integer. If you want to use unsigned integers, you have to kind of jump to the next one, which is short, 16 bits, so that you can use it for unsigned 8-bit integers. The other thing that we want to look at is so you can use so this in general, you can convert a character, a char type, to an int type, integer type, and what it does internally inside JVM, obviously in the memory, this character A is represented by the ASCII value, right? And you can also initialize the ASCII. So we're going to ask change char ch equals a to initialize it with the integer value. To initialize a char variable to an integer value, you can use a typecast. A typecast is an explicit conversion. So you can say 65 but convert it to char. In this example, the value 65 is explicitly converted to char. Type using a typecast. The resulting value of the char variable will be letter A because it's ASCII. It's a Unicode character. Note that you can only use a typecast to initialize char variables with an integer value. If the integer is within the range of 2 byte, remember char is 2 bytes, so 2 byte goes up to 65,000. Now this is an integer literal, so what are numeric literals in Java? So literal is literally what you type in your source code. What the compiler sees. 65 is not a variable. A variable is just represented by memory address, right? It's pointing to some memory address that has some values, but 65 is not a variable, right? It's literally a literal. Okay, next we'll see what are numeric literals in Java. So in Java, a numeric literal is a sequence of digits that represents the numerical value. So the digits are actually in the source code. And when a compiler sees that, it means those are literally the values that you put in the source code. Numeric literals can be of various types, such as integer, floating points, and so on. Here are some examples of numeric literals. An integer literal is a sequence of digits that represent an integer value. 10, -5, 0, these are literally the integer literals. A floating point literal is a number with a decimal point, 3.14 minus 0.01. A hexadecimal literal is a number represented in the base 16. And it starts with 0x or 0 capital X. When you start a numeric literal with 0x, it means it's actually represented in the hex format. So FF, and each one of these, we know that in base 16, each character represents a 4-bit. So FF means 8 bits, that's everything is 1. 100 means 00 is basically 1 byte, and then 1 is like 4 bits. So this is more like 12 bits. And octal literal is base 8. Everything goes from 0 to 7. And then it begins with the prefix 0. But it doesn't, after the 0, there is no X. So be very careful from this in Java, because you might assume that if you write 077, the compiler Java interprets this as 77, right, in the decimal. But that's not the case. So be very careful with adding this 0 to the beginning of your integer numbers. Unless you really want to use octal base 8, definitely don't add these zeros to the beginning. Otherwise, you're not going to get a decimal value. A binary literal is like a hex literal, but it starts with 0b. So 0x means hex, base 16. 0b means binary, base 2. So you literally write every bit. So 0b 1010 is basically 4 bits. 0 capital B, the same thing. So a small b, capital B, the convention is always to use the small letters like 0x or 0b, small b. And then again, for base 8 or octal, you don't put any letter after 0. You just write 0 at the beginning. So be very careful from octal. It's different from the decimal. All right. And then the next is show me all the ways that we can initialize an integer variable with literals. So you can assume that based on all those numeric literals, we can initialize an integer value with either base 10 literal like decimal, or hex base 16, or octal base 8, or binary base 2. You can do that, and when you print this to the console, the print function always prints the decimal unless you explicitly ask it to use another. So you can initialize an integer with the decimal. With octal, remember 0 at the beginning without any letter after that, it's octal, right? So 10, this is base 8, so 0 and 1 is basically 0 1 0, it's 8, right? In base 8, and each one of these is 4 bits, again just like hex. 7 7 is 63, because 7 multiplies by 8 plus 7, 63. And again, in octal base, each character is still 4 bits, representing 4 bits in octal. Hex, each character is representing again 4 bits, but in base 16, A is 10, FF is 255. And then binary, each character is representing 1 bit. Okay, again, to finish this, in decimal, each character is representing a decimal value. In octal or base 8, each character is representing 4 bits. In base 8, in hexadecimal, each character is representing 4 bits. In base 16, in binary literal, each character is representing 1 bit in base 2. Note that all of these literals represent the same value, but they are represented in different number bases. So I hope you enjoyed this lecture. Please stay tuned, and I will see you in the next one.